just become a free
Ooh.
Ember game where he's gonna
Oh,
be
whoa, man, the game just started. Sweet.
farm, and he's gonna have this, tether where he's able to just get super boost up from overcharge with his multi-shot in fights. But the group up from T1 is incredibly powerful. Their team fight is crazy strong when they rally around the Medusa. So yeah, we'll see how it all plays out. See if Fnatic can get themselves in a good position to allow this Ember to make space for Drow. Oh,
It does feel like Ember is, is going to take a little bit of damage, but Tether's back up. They don't have the greatest supports to rotate on tier 1. So I wonder if Armel is going to consider early just to try and avoid this lane and just maybe pull the creeps over to the small camp or play, just have two separate lanes almost versus Carl, because knowing that it's a bit difficult for a Treant Protector to come and
they put the Ember
some damage or even the Bane as well.
I mean, early on, Ember has a little bit
I'm
of
mostly going to be
advantage,
watching
but
mid.
then at level
I'm not
3,
sure what Armel will do. He's got the Flame Guard level 1, which from the changes and all that, it's become a little better versus Necrophos level 1, as you can absorb the first... You can absorb the first pulse now. You couldn't do that in the past, so other little changes,
One more right click with the slow from the snake.
Oh,
live one. Licking his lips, he finds first blood, and T1 are on the board.
Oh, I love it too. He went for the Orb of Venom. They know that this is a strong IO Mars lane, but it needs a couple levels to get strong. They're very strong level 1. That's always the power of Treant Protection. That level 1, level 2 is one of the strongest.
Even though they cut down some of the trees, they do have the 2-on jabs. Maybe White Ones overstep the mark a bit too far.
You got to be careful though. Like the Leech Seed is something you can't overextend into. It's a crazy amount of healing this early.
Oh shit. Alright, alright.
Bottom lane off to a ripper start for tier 1, and that was one of the lanes for Fnatic. I was expecting to go a little bit better, but like you said, it's just the early levels is the concern as we move to the top. Genuel, the Undying, and Raven on the Drow Ranger. A little bit of pressure into Cuckoo, who doesn't have any regen.
I feel like Undying should not be...
No, he does not.
Taking that much damage. I don't know why.
You have a lot of regen lacking.
Oh,
He does have extra being brought, of course, but...
Okay,
looks like Cuckoo's gonna actually get... Okay, oh, he missed a couple free last hits there, but
Holy shit.
he might actually get some better farm than I thought he would. They're getting good lane positioning.
Okay. Oh, buffering.
Kind of multiple ways you can play the Undying in a lane.
I don't
it's always
feel like the Pangolier is actually going to be that effective.
How you think about even leveling in general,
but we
that
there's
sometimes it's
so
just
much
spam
tank
abilities, bring out a bunch of
no
mangoes.
real way to like really
Venom can be something you consider.
I mean, I guess just
especially when you have like a carry that can provide another slow.
I feel like that's the only reason that
yeah, and then it's like,
exists.
you can choose to either go for a soul rip and a kill, or like just a heal sustain kind of thing, or you play, if they overextend, you drop Tombstone and go for double kill on your core. Something like that. That Raven, top CS, looking good. So far, Genuel doing his job.
Seems like Armel's actually, he's standing.
Yeah.
His ground against Carl is not taking a lot of damage and playing off the back of the bottle and the water runes as well, which he does still have one more top. But I think now that Carl is, this is really where it starts to be a difficult lane. You needed to ramp up your levels, and now to the stage where very awkward for Armel to play.
Yeah, this is where it's just you start getting out sustained. You have to make moves for bottle, while Necro doesn't have to go for this at all. He just goes for stat items and just regens off the creeps.
Bottom, so. Okay, this Medusa's not
tough matchup, but yeah, first 4
bad.
levels, I think Armel held his ground very nicely.
Right now, kind of being on.
The Mars should
Another
actually
pause?
be doing much better.
And that's T1 pausing.
Yeah,
that
better,
concerns me.
Actually, still pretty good.
I was just gonna say the series has kind of been off the back of the.
I guess we're just waiting for
we saw game
we're waiting for
my
client to show up. So we got another 5 minutes to chill, relax, watch Dota.
A bit of a different
fun
pace for Carl the Necrophos, but see if he's able to follow suit and follow in that momentum. It's definitely a hero that they like giving over to Cuckoo pretty often, but Carl has shown in the past that he has what it takes to play the Necro.
Yeah, and he could become also one of those unkillable Necros this game again too, right? Like the magic damage is a little limited unless they get like the Gust silence on him or the Ember's able to full commit onto this Undying. When he's got his team rallied around him, it could prove to be problematic to kill him.
A lot of sustain
he just does get Ghost Shroud off. Like The Ember and the Mars spells, really.
They
They're
don't
gonna
have
be doing
much
most of the
damage.
so.
The Medusa actually has to carry this game.
Alright, he's back. Other cool thing is just to point out, I like when I see teams willing to just like swap what role they're gonna play of like 4 and 5. Like Whitemond's playing Tree. So, speaking of Whitemond bottom, level 2 leech seed.
Standing his ground, they'll push back jabs, but
Oh.
have to get the kill as jabs limping away.
Dang.
You're seeing that this T1 bottom
that's
lane
pretty
is
close.
able
That
to
was
put the pressure back onto
I'm
Fnatic.
wondering what's the Medusa.
I
gonna
love
build
this
here?
skill build.
Double range.
I really want to point out for
Actually,
a
I've
lot of
not
people
played
at
Medusa
Tree,
in,
they
like,
just
a
like
really
default
long
and
time,
you
so
get
I
you're like,
actually
oh,
don't
I'm with
even
a
know
ranged
what the
hero.
build is.
Nature's Grasp isn't really
But
that
if it's
good,
like
but this is
how
what,
Medusa
an
usually
amazing
played in the
ability
past,
for
it's
trading.
probably
It's one of the best.
gonna be
The damage and the healing it provides for you,
damage
it's
item, I think.
absolutely insane. It's like 160 healing damage.
Yeah, it's definitely manted.
So, Gabby,
I want to say
step up a
I
bit
wanna say
far now while
they
the
just
tree is pulling.
buy a Daedalus
Takes
on
some
her
rest.
after the Manta style, and then just like.
Other
just
little
would
thing
go.
is that Raven was forced to
Like at the
put a point in
25
Gus
minute mark.
just to hold
Yeah,
back
that's the
Zephyr
25 minute mark.
and
Medusa's like,
Cuckoo
okay, got
early,
Daedalus
so we
ready
don't
to
really
fight.
see like a Gus super early in the laning phase, so
The
maybe
mi-
this can minimize some of their kill potential.
Let's fix
I
the
think
audio.
this is
Hold
a
up.
build that almost every drow wants to go. Like, I think everybody tells themselves to, they're like, if I don't skill Gus,
Alright.
I'm gonna die in lane. And then they don't skill Gus, and then they die. And you know, this is just like, he's learned his lesson. He doesn't need that extra point in Frost Arrow. Gus is one.
There we go. Hopefully.
I like when I see people actually take the skill points. Like when you're a Necro and you're like, ooh,
Alright,
I
cool.
could take that third point in nuke over my Ghost around.
Yeah, well, that's what we saw in the previous game. He was level 4, and then they were putting, oh, actually top lane, Tombstone down. Nice
Oh.
read though. Cuckoo
Wow.
and Zephyr just turn it back on the Tombstone. Now this gives them a big window to beat onto Raven.
He's in
He's
trouble.
gonna try and stand his ground with the
Oh.
multi-shot, but it doesn't matter.
That was
T1
big.
surrounds him with an easy kill, and Januel's
Man,
gonna
how
flip
do they-
out
how do they
of
even get
Menos,
that?
Just gonna rely on the movement speed
Like,
to try and chase down
That
Zephyr.
drow shouldn't be nowhere
Just
near
edges
death at
out.
all. Fuck.
Faster escape as off to the other side. Fnatic, they also lose another hero in DJ on the eye.
Okay. The IO is TP mid.
Alright, pretty huge.
Oh,
The team
okay,
with
Ember's
Medusa
actually
kills that
not
Gus in the Medusa lane
too
as
far
well.
behind.
And your lane swap.
Oh
you're
wait, no, those are
dominating
mostly
the mid
jungle
matchup,
creeps.
and
Yeah,
now
no,
you're
he's pretty
even
bad.
getting stuff
Down. He's like 500.
more than I
He's
thought
like
he
500
would be.
down from the
On
necro.
top lane,
That
it's
ouch.
massive. I wanted to see if he was going to go
Jesus.
for the build that we saw done from FBZ, especially when he's playing versus hard right click. He goes Vanguard most of his games on Pango, but Cuckoo's going to go more standard arcane boot, just corrosion. I was just curious if we would see
Oh,
that Vanguard build.
This
from FBZ.
Bane
It feels really good.
making
Zephyr,
Ember's
look at
life-
him being annoying.
he took the regen rune and then now he's taking the XP too. But Ember has 6. It's fine. He's gonna start
What are
rotating.
going on, Mel? They took
Look at
away
him,
the power and jeez. we saw
Look
these
at
in
him,
game
yeah.
Oh
1.
my god.
Are you serious?
He might actually.
I was like, dude, I actually can't fight you. Like, I gotta run.
His brains have the threat of it. It's a lot of damage.
Holy shit.
I mean,
oh
that's,
no.
Okay.
that's
So this Ember is not gonna be able to
big players
rotate,
coming up from
but it
Florida
doesn't really
doing
matter.
this.
This Medusa will get
Alone,
kicked out lane
getting
eventually.
his own stuff top. Bane is disrupting the Ember's farm while Necro free farms, Dusa free farms. Excellent start in the lanes.
Yeah.
And like you mentioned, you know, Fnatic, they set themselves up with two
Yeah,
strong side
T1's
lanes.
actually got a pretty good
And,
grasp
yeah,
on
they're
this.
not winning those.
Would
Okay,
you like to see
so what's
T1
Drow
maybe
gonna do?
bring supports mid to utilize
I feel like the comeback mechanic here is that the Ember links up with the Mars, and they start
I
making
thought
plays on the
the
map and try to
I don't
pressure
think
this
Tree
Medusa a
ever
little bit more,
wants to
but
beat Medusa at this point, so yeah, that's just about it. I thought that's why I said.
oh
the
my
7-minute
god,
tower,
is
you know, I
Mars
got-
actually getting pressured?
but
Holy
I
shit.
thought it was a
Wait, this
possibility.
Medusa's
Necro
level
got
6 already, holy
700
shit.
damage, which is pretty nice. And the Bane was
Damn.
annoying. Maybe
And
he
here
was
I thought the
trying
Mars was gonna actually push out the Medusa.
What is happening? Are they chasing creeps?
Yeah, they're skipping the creeps. They're skipping the creep wave now.
His
Hello?
remnants?
His
Gonna
remnant just
expire.
timed out.
No remnant.
It just
Wait,
timed
he's
out.
gonna die
Shit.
from this. They still
Oh.
have the brain zap. No way.
Oh my god.
They're
just the Ember's just trying to cut creeps. I think he's just trying to wait for like phase boost or whatever he's gonna build. Power treads?
But DJ with the sustained will keep jabs.
Either no, I think he's buying power treads here.
He's
Oh
gonna
my
TP all the way
God.
back
Holy
to base.
shit.
This is not looking good for Fnatic.
It literally timed out what, like 2 seconds before they get the sleep on him, or like a second before this. Oh my god, how unfortunate. Poor Armel. And now the tower is gonna start getting pressured as Whitemon. The bottom lane is broken, so now
I actually don't know what the comeback is here. You can't pressure the Necro.
A little bit.
You pretty much have to bully the Medusa, right?
Not a good sign for Fnatic versus Adusa.
All right, well it's 11 a.m. We'll come back to this game later, but let's see.
And that's gonna Carl is just rushing a vessel also. Since he's playing versus the Io and the Undying, the double heal supports, he's just going to be the one to get it at an unbelievable early timing of, like around 10 minutes, if not before then.
Again, the side lane should not have gone as well as what they did for T1.
Yo, hello? Hello?
You hear me?
Yeah, I can hear you.
Perfect.
Cool. Yeah, I saw your little blurb.
Yep.
Yeah, I guess give me the rundown if there's any details that I should know about, or is it just been practice and kind of just waiting?
Exactly this. In practicing, just kind of waiting.
Okay.
And well, I did one mock interview actually as well.
Okay, how'd that
And
go?
since that we are on the same level in terms of like quality, you know.
Okay.
My friend said there's like only one nitpick, you know, because I instantiated one pointer and didn't use that. But other than that, he said that, yeah, no comments in terms of like testing and like creating the idea. I just had like a few troubles with like one question actually today.
Yeah.
You know, like to search one string in another. Like, and there's a very fancy way to do this, and I never thought about it. But yeah, I just think like your vision is better. I don't see anything else.
Yeah. All right. I would say that right now if it's like where we left it off before, I think you are pretty much you're pretty much interview ready. We just need the signal from like the on-site, see if we can adjust ourselves. So I would definitely like trying to apply for other companies is good, like Dropbox or like either some non-fan companies that can still pay you pretty well. I think these are all going to be like take your shot at all of them.
I will.
Yeah.
I'll take some time just for this. What do you think?
Yeah, just like start applying. I think at this point you're pretty much there. And so let's see. Okay. What else? Amazon Process is only on next month. You mean? What does that mean? Did you?
Yes. Sorry about that. I told you. I think I was like kind of eager, right, with those process.
Yeah.
And I mistake the month while saying to you, you know, it's for next month.
Okay, so it's not for April, it's for May. All right.
No, yeah.
Okay.
And I received a referral from GoDaddy. I think I wrote on the blurb.
Yeah.
Actually, one guy from the server. And yeah, I applied for 5 roles, and Google, like I applied for on Monday, you know. And actually on Wednesday they sent me a form, like with ask me for extra information.
Okay.
And I emailed Microsoft as well. And the recruiter said that I still on the time frame for the answer.
Okay.
And because it can take 4 weeks, and I'm still on the 4 week. And that's pretty much it. I sent you the prints there on the score.
Okay, that's fine. Let's do this. Let's look at some of the I guess some of the mistakes that you made, and then let's actually do a mock interview. I think let's keep it there for now because I don't want to do anything like anything too heavy right now until we have a better.
Let's keep what? I just don't get it.
Oh, I don't want to do anything like too stressful or heavy until we have a better idea of what our schedule is. So let's just stick with I would say one time a week for now. And
that's good.
Okay, so and let's see how today goes. All right. So let's look at some of the things that in your practice diary and problems that you did. Do you have any particular problem that you struggle with or anything like that?
Let me see if there's a better one. Hold up.
If you send me the link for your practice problems, I need access.
I sent you.
I need access.
Oh, yeah, access. Sorry. Hold up. Any person with the link. Try it now, please.
Okay. Cool. All right. So let's see what problems you struggle with. I feel like you shouldn't be very many right now, though.
Yeah. But like I mentioned, like those details, you know, I'm not satisfied with this.
Okay.
You know,
Let's
like sometimes I get like the entire idea pretty easy now, I'd say for most of the problems. but like sometimes like few things, you know, like that I must be very aware of. And yeah, let me just check if there's one very cool.
Yeah, I'm picking. I'm gonna look at this one. But yeah. Give me a problem that you think you did bet good well on, and one you did poor on. Let me see. Hypothesis test small bit. Okay, sure.
I think the spiral ordering of a 2D array I did pretty good, you know, even though I took 30 minutes. But for this first one that I think you were actually looking for, the Dutch national flag, not the idea, you know, but like I kind of run in some loop and kind of did the thing as you mentioned, patch and pray, which I acknowledge where I was wrong. That's not cool, you know. Like, it must be perfect.
Yeah, I got you. Okay, let me finish reading this one. Work with the indices and shrink the element visited. I'm not quite sure what this one means. Traverse the matrix in 4 ways. Okay, I get. Yeah, this one makes sense. Once finish the traversal on one row or column, shrink the matrix, but in the equal specific row. I know what you're trying to say here, but I think it'd be better worded.
Better worded.
Yeah, once the are equal finish. Yeah, it could be better worded. I know what you're trying to do here. You're doing this right. You go left to right, top to down, right to left, and then left to up, and then you shrink by taking off one shell or one row and column around the entire matrix. I understand what you're trying to do here. I just think it could be better worded. Let's see. So range between left bound and right bound. Yeah, okay, that's fine. Yeah, upper bound plus 1. Yep. I think this pretty much works. Did you plug this into the test?
I plug into I run on my compiler.
And like, did you try testing it?
Yeah, I tested. It worked.
Okay. Yeah, as long as you plug into the compiler and then give it like a 3x3, and then maybe a 4x3. I'm curious, like, is it is it a square or can it be a rectangle?
I did for like it worked for n by n, but like I assume that it will be n by n.
Oh yeah, bad.
It can be.
It could be a
no, but like my solution, I acknowledge that it can work for anything, for a rectangle and a square.
Okay, I mean it looks like it can.
Like why? Go ahead, please.
Yeah, I say yeah, it looks like it can.
Yeah. Because at the middle, I'm verifying if like the bounds collide, you know. So there's no problem. Like if it was a rectangle.
Okay. Yeah. That's fine. I think I just would have been a little bit more cognizant of, hey, is it really going to be square at the beginning? Just, is that little check, like, is there anything we're assuming here that shouldn't be assumed? So, other than that, yeah, the solution looks fine.
As you can see on the hypothesis for tests, I just consider like a small value, like 1 by 1.
Yeah.
I thought about considering like just imagine one line or one column, but like I assume on the book was saying that was a n by n, So
okay,
I assume that would be squared.
Okay, that's fine. Yeah, that's fine because I think if I were to give this problem in the real world, which I don't anymore, I used to, but what I usually do is, well, for one, this small value 1 by 1 matrix, I would expect a candidate to do a 2 by 2 and then 3 by 3. Because once you handle 2 by 2, 3 by 3, you are pretty much golden. Because the way the box shrinks in each one of these scenarios is different. So, like in the 2 by 2, you'll have to do one pass. 3 by 3, you shrink the box, you still have the 11 to deal with. Like, you still have the middle element to deal with. And then usually for a follow-up, what I would do is like, okay, well, does this work for a rectangle? And then, like, I would say maybe 60% of the time it does, 40% it doesn't. Usually the candidate should be a little bit better about making their code more flexible. So that's just really that exercise. So it's fine.
Okay. But at the first moment, you would consider that just for, like, squares, right?
Yeah, I would, the happy case. I'd try, like, make sure I got my square case down and then make sure that, hey, is this really, can we use rectangles? On this if the problem didn't specify. But if the problem specifies specifically a square, then you're fine.
Okay.
Okay, cool. So that's fine. What's a problem that you felt like you struggled with?
The first one, you can go on the first page.
Oh, okay, Dutch national flag.
I struggle in terms of like I as I mentioned, I got the main idea.
Yeah.
right? The first one. And like, but as I mentioned, when I was doing the test, I run in my compiler
Yeah.
just to see if that work. It ends in a infinite loop.
Oh.
Infinite loop. Yeah.
Okay.
And that's not good. And I tried to solve by myself, and yeah, that was like conditions that I was putting in the wrong, like counters that I was incrementing in the wrong place.
I see.
And as you mentioned, if I don't get the final answer, that's a pretty red flag that I should be pretty aware of.
Uh-huh.
And yeah, I did the delta with the book to see where I messed up. Yeah,
Okay.
that's pretty much it.
Okay, I see. Yeah, I'm very curious to what happened here. So, quicksort algorithm for sorting arrays proceeds recursively. It selects an element pivot, reorders the array to make the... Oh, this problem. I'm gonna tell you, I straight up hate this problem. I understand why it does
Why?
this. Huh?
Why you hate this problem?
It's just that it doesn't test anything. It doesn't like tell you how. Like it's just a toy problem, and it doesn't really test you. It doesn't really like. What's it called? Help in learning how to be a better engineer and solving the problems. It's just a toy problem. That's the best way I can describe it. It's like it exists in a vacuum. So
Okay.
I'm not too concerned if you weren't able to solve this, but I like the way that you at least try to approach and try it. So I'm just gonna do a quick look here. Inefficiency too much. Yes. Better approach, save space. You can do 3 pass, but order in place. Yes. First order the zeros in the beginning. First order the ones and twos. Invent too much time since order n squared. Share the animals one by one. Swap. I mean, I think this looks right. So
It looks, but it doesn't work.
while start
Like the
indexing
messed up
this-
answer. It's like if you go on this page, yeah, that's the wrong answer.
Okay, let's see what you did here.
And that's the right one. That's the right one? Yeah. No, hold up.
Start
No,
index.
yeah, that's the wrong one.
You mean
That's
start
wrong.
pointer? Okay. Alright, start pointer equals 0. So in order for this to go into an infinite loop, the start index or end index cannot be adjusted. So this would not execute. This would not execute. So start. Okay, I see. Yeah, I'm curious what they say. All right, start index -1. Is that it?
Yeah. No. Where are you seeing this?
Bottom.
No,
Adapted.
start
This one.
and index. Yeah, actually, I adapt this answer based on the API.
All right,
Let
I
me
would
double
still
check
test this, but yeah, I think that's is that really the only issue that you had? Oh, I mean, you also have start pointer here as well, but instead of start index, but
No. Hold up. Let me check here. It's actually -1. It's actually they're comparing equal. Start in. Yeah, I think. Yeah, it's because I try to adapt my answer, but not copying. Like I try to adapt to make it work. And yeah.
all right. Anyway, so it's okay. Other than that, I'm not too worried about it. I think the logic that you go through is fine. All right, do you have another problem that you want to talk about, or you think you're good?
Let me see here. Oh, there was 2 problems here that was kind of, as you mentioned, if I have a pretty clear understanding of how to do it, just double check.
Okay.
And I didn't put on the spreadsheet, not on the sheet
Okay.
that you have here.
Okay.
That is the increment the arbitrary precision integer. Like when you add one number in an array and you should to increment, just the math, just an addition operation.
Where do you see this?
No, it's not on this.
Oh, it's not on that
this
sheet?
practice sheet.
Okay.
Because I have like the understanding, and I I just wrote like on the code editor just to make sure and double check with the book was pretty much the same thing, you know, like exactly the same thing.
Okay.
And the other one was to validate a Sudoku, you know, and actually, it's just matter of efficiency because it's just follow the rules of the Sudoku, you know, rows and columns and the 3x3 like groups.
Okay.
And I prefer to go into the problems that I was not so sure to how to solve, as you mentioned, you know,
Okay.
so I can get most value of my time.
Got it. Okay.
But other than that, I think that's pretty much it. As you can see, like this week was kind of there was not much problems because, like my routine just added college now.
Yeah, that's fine.
But I'm trying like to fill the gaps.
Okay, but it doesn't sound like you weren't able. It sounds like you're able to like solve almost all the problems regardless.
Basically, yes. Yeah. Is if you can see like the colors, I put like most of them are green. You know.
Okay.
'Cause
Yeah, look,
there's no much of like this point of I get stuck.
yeah, usually if you can get to that, yeah, that's what I said. Like you're pretty much good for interviews right now. You're not. Doesn't seem like you're stuck on anything. So it's a matter of just getting those interviews.
Yeah, I'll probably be stuck in some. Being honest here, like probably in some dynamic programming questions.
That's yeah. I mean, dynamic program is not that easy, so I expect that.
Yeah, but other than that, I think that's pretty much it.
Cool. Okay. Yeah. Okay. Let's. If that's the case, then let's actually do a problem, do a mock interview, and then let's see how that goes.
Okay.
So let me go to your sheet here. Let's see, problem sheet M. All right, cool. I opened it up.
You're gonna use the prep doc or what?
The problem sheet.
Problem sheet. Okay.
Here, let me. Do you want me to link it to you?
Yes, please.
Okay. There you go.
Here we go. Here I am.
Cool, cool, cool. Let me pull up a problem then.
Did you just change the account? Yeah, there we go.
Okay, let's see. Let's see. I'm starting to pick one out. I'm just like, which one would be a good one at this point? It's like it's kind of hard.
You're just like my friend. My friend is the same thing as you. He's saying, man, I was trying to find something that put you in challenge. You know?
Okay, let's see how well you did on this. I'll do on this one because I think it's been a while, but I think you might. And I remember the first time we did this, you didn't really do well on it. So let's try this one again.
Oh.
All right, ready? Let me
Yeah.
timer
Let
out.
me let me put my timer as well.
Okay.
So we can.
Don't worry. I would say
There we
don't
go.
put your timer on. Just let me do it. All right? Because in a real
Okay,
setting,
so
you're not gonna
let me
really
close.
have access to a clock.
Okay, yeah, you're right.
Yeah. So, all right, let's go. So serialize and deserialize a general and array tree. So in this case, when you say serialize, I want you to convert this tree structure. You're going to be given a tree structure, and you're going to convert it into some representation. And then deserialize, you're going to convert that representation of the tree, and then give me back the tree. Does that make sense?
Yeah, totally.
Cool, cool.
Okay, so for the first thing, I'll try to separate like the things we need to do. You know, so first I'm gonna think about the serialize and then the serialize.
Sure.
So there we go. talking about the serialize. So basically, what can I see here is that we must find a way that we like store all of the elements in of this in our tree.
Yep.
Then we can know which like who is the child of who here. So yeah. So for example, let me try A, B, and C first. Basically, I can have. Yeah, basically, my biggest things to be worried about is like this thing of know which one is the child of what,
Okay.
and like this the separation between the childs.
Okay.
So basically, I can use a or a. So imagine that I'm traversing through A,
Okay.
just in a normal like in a normal in order traversal. So
Okay.
yeah, and then I will check that A has a child,
Okay.
and I can put a B,
All right.
and yeah, I'll check that C has two child, E and F, right? Then I open up another parenthesis here and put E, and yeah, and then like E doesn't have any child, but there's another child on F. That is the child of B. So
Okay.
there we go.
Sure.
And yeah, now F has one child that is K.
Okay.
Okay, so basically reproducing this to the other side is going to be pretty much the same.
Okay.
Now let me just focus on like how the logic is going to work here, so I can have the separation of like let's say childs and like they're like yeah childs and their brothers, if I
Okay.
can put like this.
Sure.
Basically, okay, like what defines so is it okay if I assume that references for the childs are gonna give in like in a list of childs for each node?
Sure. Yeah. You can. Yeah. Define. Yeah. You can get a list. That's fine.
So for example, yeah, node, and then I have data. Then let me just yeah. Data and childs. Here are the reference for them, and here's the value of the current node. Okay. Right. Now, basically, I'm gonna be into like I started any it can be a depth first search, like yeah, an in order traversal. Basically, go into the last child and then going back to its parents. So just in a depth first search manner. So like I will visit the first one, the first child, no, the first node, and I'll check that the list of childs it's not empty. So like for example,
Okay.
I will visit first node, and yeah, if the list of childs is different than 0, then I do like recursive call for the other level, the current child or the child. And that's pretty much it. And like actually, like if the list of child is different than 0, so I need to like traverse
Okay.
through all the childs. I'm just gonna worry about the traversal first, and then I will check where I'll like create the string so I can deserialize later.
Okay.
So imagine actually that this is a string, right?
All right.
Like I'm creating a string here. Okay.
Okay. So then traversal children, but then like you still need to describe what you're doing at each step. So I'm kind of curious what happens.
Yeah. So here I first go in. So imagine that maybe this is gonna be my function. I'm just gonna like test it. But my
Sure.
intention is to visit the node, the first
Okay.
node. Okay.
Yeah.
Then check if that current node that I'm visiting have childs,
Sure.
like that list that holds the childs.
Okay.
If so, then I will like traverse through the other childs
Sure. And
and like
yeah, I get it. Yeah.
yeah.
But the thing
Yeah,
is that
that's
you
pretty
still need to
much
produce. This doesn't produce a string just yet. So
No, it doesn't produce. I'm gonna worry about this now.
okay.
So yeah. Okay, so visiting the first node. So the first thing I can check here, the first pattern is like if the list has a child. So as we can see, like there's these open parentheses here, you know. Hold on. So I must to open the parentheses when like there's childs on the node, you know. So and close parentheses when there's no more childs.
Sure.
So yeah, I'd say that at this point before we do the traversal, we're gonna open parentheses.
Okay.
Parentheses. And like after traverse all of the childs, I'm gonna close parentheses here. Yeah, close parentheses. But now I just need to be worried about like the other thing that is like when I have when the child doesn't have like when the actual node doesn't have any childs, I just need to put a comma so I can deserialize later. Basically, yeah, I close this, and by any, it doesn't matter if the child doesn't have, actually the node doesn't have childs. What I'm thinking to do, yeah, it's in this point, add a comma. Okay. I'm just going to, let me just see one thing here. So first I visit the first node, and then I'll check that this has a, actually has childs, then B,
Okay.
right? And then I open the parentheses,
Okay.
and then here I am on the B. I will like concatenate this. Okay. Actually, I'm not, there's no step for concatenate the current node value here. So let me check where is the better place to do it. So basically, after I visit the node, I can do it because like, yeah, because it's like before the child appears, for example, B, I know that I have E, F as childs. So in case I don't have this, then it just, I'm not gonna fall into this if case here, and just let me put the comma as a following action. So I can basically concatenate the current node value here, and yeah. Yeah, okay. Recursive call for the current child. Okay. I'm just gonna run a about how this pseudocode is gonna behave on the example you gave me.
Sure. Sure.
So, like, let me see if I'm producing the output that I want. So first, I visit the first node, that is the A. Then, yeah, I concatenate this as the following action. Then the list of childs, it's not empty. We have B, C, and D.
Okay.
Then I will open parentheses. That is actually the accurate instruction is concatenate the open parenthesis
Okay.
here. And there's concatenate a close parenthesis. And then like concatenate, open parenthesis, and then traverse through all the childs. So basically that can be a for, and recursively I'm gonna be on B. A and then B, and then I will concatenate a B here. I'll check that the list of child is not empty. So yeah, the same thing here. I'll open parentheses here.
Yeah.
And then put an A right here.
Okay.
I just want to check that if it's gonna work with the commas.
Uh-huh.
So, and yeah, here we will traverse through the node A.
Okay.
And the list of child is gonna be empty. So
Okay.
this if, we're not gonna fall into this if case here.
Okay.
We're just gonna go into the add comma statement.
Okay.
And we concatenate a comma here.
Okay.
And yeah, we just visited D8. Oops, I'm doing
Alright.
it. Go back to B and F. And yeah. Recursive call the current child. Hold up. I put it right here and then I'll backtrack to B. I'll backtrack to B, and by backtracking to B, I'm gonna visit the next child of it, that is F. And then, I will concatenate the F here. I'll check that there's one child, and I'll recurse to it.
Yeah.
That is the K, actually, and then I will open parentheses.
Okay.
And K, it doesn't have any child, then I will recurse.
Okay.
So going the logic here, F, and then K.
you
I'll
add
go
the
back to
comma.
F. There's no more childs, then I'll close it.
Let's see. Okay.
And then put another comma here.
All right. Cool. So then now you're at K. You're writing it back
Yeah.
up. Okay. Keep going.
Yeah, but there's a problem here. I
Yep.
just saw. Imagine that our tree is just composed of A, B, E, F, and K, right? Just for sake of
Yeah.
be simple here. There's an extra comma that I think we don't need here.
Correct.
Like, no, but yeah. I'm just, because by backtracking to F, there's no more, there's no more child here. So, and then we're gonna backtrack to B,
Well,
by
if there's no more
closing the-
child, then you're gonna add a close parenthesis based on your algorithm, then add another comma.
Yeah, another comma. So
Yeah.
that's the problem.
So you have a problem.
I just addressed here.
Mhm.
Let me check. In the real, for real, I don't need to add this extra comma. It should be something like just closing parentheses as
Yep.
on the upper example. So let me check. Yeah. So basically, concatenate the close parentheses. That's clear. After I traverse through all of my nodes, then I don't know, beforehand, if I would have following nodes to traverse. So maybe this add comma, it's not in the right place here.
Yep.
I'm just checking based on the flow. So A, B, all right? That's pretty clear, but when I'll backtrack, yeah, for the E, it's gonna work. Okay, yeah. Here's one thing.
Okay.
If there's actually, if the list of child is different than 0,
Okay.
then I'll traverse through all of them, close the parentheses and add a comma.
Okay.
I'm just trying to change where I need to add this.
Okay.
Mm. Hold it. So I would try another thing, like instead of adding this comma right here, maybe so like based on so A, B, okay, and I just want to check the backtrack. Okay, so one thing that I can do is like instead of add the comma on the recursive call after, because our problem here is that we're adding a comma without knowing if we're gonna do another recursive call. So we might end up with a comma that doesn't work for nothing. I can instead of doing this, I can add a comma based on like the traversal of the childs, you know. So like I would traverse through all of the childs,
Okay.
and for each child that I do a recursive call here, just okay, I'll put a comma here. Recursive call. I'm just worried because okay, if we put a comma here, it's gonna be the same thing.
Okay.
We can traverse through the last one
Okay.
and add a comma, you know.
Okay.
So
So you need to just add a comma at all the children except for the last one.
yeah, except for the last one. Yeah, you're right. Okay, so there is plenty of ways to do this, and I'm just checking the best one. Yeah, basically, we can traverse through all the childs
Okay.
minus 1. No, I think that's not going to be a good decision. Curse. Yeah, so yeah, actually, we can do a statement here, like if the current child index is not the last one,
Okay.
and we just do this, like
Sure.
let me just the margins here, just to be
Yeah.
clear.
Whatever.
Then I do this statement here.
Okay.
Otherwise, like, that is if I'm in the last. I just do recursive call.
Okay.
So, pretty much it.
Okay, that's fine. Sure, that works.
Yeah,
Okay.
that's pretty much it.
Okay, I think that looks right. I think that looks about right. Why don't you write the code for it?
Yeah, for sure. Like, my idea is first to have a main function, right, where it's going to be called, and then we're going to have a helper function
Okay.
that's
Yeah, I
going
mean,
to
you already
be in
wrote
charge
the
of
pseudocode for it, so you just translate that.
this like recursive part.
Yeah.
Okay, so serialize in tree, and we're gonna receive the root of this tree. That's pretty much it. And like what I'm thinking to do here, since the recursion works as a contract, I just need to check what I need to pass. So like at the end, I just can return the string that this upper function is gonna do, recursive, and then I'm gonna need like the current node that I'm visiting. So start by the root. Like the I'll start with an empty string, you know, that is going to be used to serialize. And let me see if there's anything else I need here. I don't think so. Yeah, I think that's pretty much it. Like the node that I am at and the string that I am creating while serializing. Then I will return. Now is the main function. That is the serialized tree. And I return the recursive. We're going to call the node because you don't necessarily need to be the root. We're going to call this a string, and that's pretty much it. The first thing I'm going to do is like check the base cases here. So one thing is for sure, like since I am Visin, I'm pretty sure that like all of the nodes that are gonna recurse, there's something like based on this tree here, there's something. My base case is gonna be checked like beforehand, before I do this recursive call.
Sure.
But there's a problem. You can pass me a root that is null.
Okay,
So,
sure.
And maybe,
Yeah, sure. Go ahead.
so if not node, and I'm just going to return the string. Nothing new here, just for the sake of the first case I mentioned. And then we do the recursive thing.
Okay.
Of like, yeah, concatenate. So I have the string, then I'll take the node value, and here I will verify if the current node has childs. So if the length of node childs is different than 0,
Okay.
I'll do something that is visit all its childs, and then I will concatenate in the string a open parenthesis
Okay.
like this, and then for actually I'm putting like for every child of childs, but I'm gonna visit based on the index because I want to keep track of like if I'm in the last one.
Sure.
So for put child's index and the length of node childs.
Okay.
Then I'll do the verification of like if I'm the last or not.
Sure.
Actually, the last node is gonna happen one time. So basically, I'm just gonna invert this logic
Sure.
of like just to verify if I'm in the last, and like
Sure.
the normal case is gonna be
Yeah. Go
like,
ahead. Go ahead.
nodes that are not in the last. So if the child's index, is equal to, the length of node child's -1, that means I'm in the last, and then I'll call this function again.
Okay.
So I'm just gonna copy this big name. But I need to be worried that this function is gonna return like another string.
Sure.
So
yeah.
since we're not passing like, since we're not passing the, since we're passing a copy of the string, when the recursion, like when we do the backtracking, it's gonna be like with only
Okay.
this current value here. It's not gonna be updated.
Okay.
So we need to concatenate the result of this function. So
Sure.
we're gonna call it like, we're gonna call it temp, just for
Sure.
temporary.
Okay.
And I'm gonna pass like node child's respective index, which is gonna be reference for another node.
Sure.
Like in here it's like child's index.
Okay.
And the current string here.
Okay.
And then I take this temp, actually like the given string here, and concatenate with this temp.
Sure.
Yeah. And then otherwise, I just need to, no, actually, yeah. Let me see here one thing. Yeah. Yeah. Otherwise, I'm just gonna do the same thing. I'm just worried about one thing. Okay. So there's no need for repeated code here.
Sure.
So if the node that I'm at is different than the last, then I need to, like, this action is gonna be done here, and then if it like is in the last, I'm just gonna add the close parent, like the
Okay.
comma, you know. So like comma.
Okay.
Otherwise, there is nothing for me to do here.
Okay.
And then, like, I just need to add a close parenthesis and, yeah, and
Okay.
return the current string.
Okay. I'm gonna pause right here because there's plenty for me to talk about right now, and it's pretty bad.
Okay.
So, I want to first ask you what you did right, what you did wrong here.
Hold up. One thing that I'm not sure if I did right is the thing of returning the string. Like, I think I don't need it.
No, it's fine.
because
It's
of,
fine.
like-
That your code is pretty much right. But think about it during the entire interview. Like, let's say
Oh.
that this was the problem. What do you think I'm going to tell you that you are screwing up on?
I would assume that the thing of fetch and pray, because I was not sure of my idea. Then I went tried to write something. I wrote something before I was like totally sure about my idea.
That's part of it.
The thing
it's,
of the comma, you know. So I had to go back and forth,
Ye-
like more than one time.
It's part of it here. I'm going to say you took way too long. Do you know how many minutes in we are?
We start in the 20. Yeah, we are in the 27th minute.
Yeah. This should have taken you half the time.
F.
Do you know why you spent too much time on this?
Let me just try to think here.
Okay.
Because I wrote this pseudocode.
Not really.
Actually, the code, I think I was pretty confident while doing the code.
Uh-huh. But do you know why you
but-
spent so much time? Yeah, the code's right. It's fine. But do you know why took you way too long to do it?
The idea was not so clear since the beginning, and it took too much time to figure out.
Pretty much, yeah. So here's the notes, but basically let's go through it. So, this is fine. The first 4 minutes is fine. You're scoping it out. I was like, okay, whatever. But to me, like, you kept going through all these really weird questions, like, should I talk about the list of children? Like, wait, you just burned 3 minutes there doing that shit. Adding common parentheses. When you're talking about the pseudocode, all you said was, I'm going to visit the node, then I'm going to traverse the children and recurse into the children. That was like on your first pass, right? But to me, that's basically nothing. The reason why is because the traversal, it's like, well, it's meaningless. You know what I mean? It's like, so what if you're traversing through all the children? You know, I want to know where you're going to add the parentheses and commas. So you kept like harping on like these points that mean absolutely nothing. Like, oh, am I traversing the children the right way? It's like, okay, yeah, you can traverse the children, but like the core of the problem is being able to add the strings. And you basically spent 12 minutes trying to figure out, hey, did I set up my recursion right?
It's not the main point, Fran.
Yeah, it's not the main point. It's like, get to the point of adding the parentheses and commas. So then, okay, you at least get there, eventually 12 minutes. But then you basically spend this amount of time trying to fix the comma code and then trying to write the code as well. Like, you spend 10 minutes, like, after all this planning, you spend 10 minutes writing the code. And then you keep trying to check yourself again, you know? So, the first thing is with the comma, right? When you said, okay, at least you caught yourself with the extra commas at the end, right? But to me, it's plainly obvious. The issue is that the comma is meant to separate all the children, right? So all you do
Yeah.
is just put all the comma in between all the children except for the last one. Instead, I think you did the patch and pray again. You didn't understand why this comma was here.
I was trying to understand, basically. I think I was kind of cautious. Yeah, I was pretty worried about like not adding anything before thinking.
Yeah.
Because this, I thought I took too much time
You were
trying
being-
to for something that was totally obvious, you know.
Yeah,
not
you're
the
being
last-
way too overly cautious, and then you keep end up checking, rechecking the exact same ground over and over again. Like even when you wrote the code, you know, it's like, oh yeah, you were like trying to fuss around with these 4 or 5 lines, but you already wrote that down here. Just
Yeah,
follow
you're
what
right.
you had up here.
You're right.
So it's like, yeah, you did all this planning, but then it's for nothing. You just ignore your own plan. So that's basically why you screwed up. It's just like you spent way too much time coding because you threw your own plans out the window, which makes your planning completely worthless.
No, but there's one thing. Like, I just inverted the logic of the if else because I thought that would be unnecessary code. Do you think that is just throw my plan?
You can refactor it later. You can always refactor it after if it's like, hey, it's a little messy, let me clean this up. But at least get a
Oh,
working
okay.
idea
Okay.
down.
Good.
Because refactoring while you go, it gets a little bit hairy, especially when you've done all this planning. It's just
I
like,
see.
it's just very simple. You have the plan, execute on the plan, and then if it needs to be revised, just revise it later. Instead, you're revising on the go. So it's like, why are we planning?
Yeah.
Yeah. And so
You
that's
just have to
basically what
plan.
killed you. It's basically you were throwing your own plans out the window. You got in your own way.
Uh-huh.
Like, yeah, it's, you had the idea. You already said what the idea was, what it looked like. And then all you need to do is, like, okay, and spend a little bit more... I would say you probably spend a little bit more time proving to yourself at this point that this is the right thing to do. And it says, oh, you said, hey, okay, I'm going to visit A. Then I'm going to add a parenthesis when I go to B. Add a parenthesis when I go to E. And then, oh, there's nothing here. There's no child at E. Then I'm going to go to F. I'm going to add a comma to separate the children, right? You even said this. And then you go to K, open parenthesis to go to K, right? At this point, it should be very clear, okay, I can at least start writing the pseudocode and just do exactly what I just said. Which is visit the node and add that first node to the, to the string. And then if the list of the child is not 0, then I add a parenthesis, traverse to the children, have them return to me the string, and then separate those by commas. Is that you already did the work, you already planned it, you already said it, you already tested it. Just write it down on paper. Instead, what ended up happening is that you basically redid it over again. Like you just said, okay, let's visit first node, list of child, and then traverse through the child, and then recursive call. And it's like, oh, I don't know where to add the commas and open parenthesis. It's like you knew what to do, and then you just threw it out the window again and again. That's all. That's it. Like, is there a specific reason why you did that?
Because as you mentioned, I was being overly cautious. Like, I was trying to make sure that I was not doing any step wrong, you know. So because of this, I think I got too repetitive.
Yeah, it's basically instead of like if you're concerned about anything wrong, do it in the planning stage. Do it like when you can easily just like run through it, you know, and then write out the idea. At least it's like if you commit to paper, then you can at least like edit it at this point. But what you're doing is you're just adding one thing at a time instead of just writing down the plan and then revising it. There's a difference.
I see.
It's like let's say you screwed up here and just like you didn't add this part, right? Let's say for instance you did that, right? Let's say you just went here and then you test the code, right? And then you realize,
Yes.
oh shit, there's a bug here, I think. You know? You could have tested it
Yeah.
before, in fact, before you even wrote this, but let's say you didn't catch it. Now it's like, oh, okay, well, where's the bug? You know, oh, it's because of an extra comma here. And you should have immediately identified what purpose does that comma serve. And then boom, you would have gotten here a lot faster. So, that's...
But like there's one point that I'm just not understanding.
Yeah.
You said that if I wrote like a bugged code, you know,
Yeah.
as you did in the past,
Uh-huh.
like I think I would be not sure about the answer, you know.
Yep.
and like I'm gonna fall into the same case of like not testing my idea before commit to a plan. Don't you think?
Well, that's what what I'm saying here is that if it happens. But what I'm saying is that you could have caught it up here before. Remember how before you basically only went up to half the tree?
Yes.
That's
right.
one part of what killed you actually. I didn't think it was gonna be too big of an issue, but yeah, because if you had just gone to the next node C and tried to do a little bit more of it instead of just one leg of it, you would have recognized this problem a lot earlier.
Oh yeah, the comma one.
Yeah, you would recognize the comma issue a little bit earlier. Instead of only doing half the example. But I'm saying if like let's say that happens, right, and you miss out on a test case, right? And then it's like you just need to be able to run through the code. But instead, what you did was like you just built you had a plan, you knew what to do, and then you rebuilt it piece by piece, and then kept testing it as you built it. Which is like it's a little bit slow, but but for code this simple, you could have probably done a little bit more. Like it's like you came up with the idea. You went and then wrote. You did a small test on it. You wrote this. And then you wrote this piece by piece, and then you tested each piece individually. So it's like overly testing when you could have just done a more rigorous test to begin with.
I see. I'll be save much more time.
Yep,
You're right.
Just be much more rigorous in your testing for the initial idea, which goes back to this thing of you only tested half the tree. So yeah,
Okay.
So
and I think you pointed out the last point here, like you're talking at every step. Why you already addressed this point? So this thing of being repetitive.
Yeah.
You know?
I want you to actually rewatch this stream after and just like watch yourself, like listen to yourself and then say like to understand what it looks like from my point of view. Now that you know like what the thing was that caused you to screw up, I want you to rewatch it from my point of view and see what happens.
I'll watch again.
Okay. I mean it's just a minor point, but I think it just basically sets up the entire thing. So let's do you want to do another problem or yeah actually let's do another problem.
It's okay.
Yeah, I'm gonna say I want you to do this deserialized portion, but I would actually let's do the deserialized portion. Now that I've drawn your attention to this issue, I want you to apply to the deserialized portion of this question. Okay.
Okay.
Okay, so I'm gonna.
So yeah.
So go down here, and then let me restart the timer.
Okay.
Okay.
So
and go.
Okay. So yeah, given the fact that we just have this string, like we define this string to deserialize. Let me just create the full string here. So A B C and I comma G comma I comma G comma H comma J. All right. Okay. Let me just do one thing here. Just a minute. Just gonna copy the tree here. Okay, B, C, F. I'm just double check here.
Okay.
C and D, and then I, G, H. I think there's one parenthesis missing here.
Yeah, I think that's.
There's one missing here because it's 3 levels of like.
Yep.
Oh yeah, actually it's 2.
I think you're missing. In your string. You're kind of missing, some commas as well. Yeah, there should be.
The comma here.
Yeah.
And C. Yeah, because this parenthesis is from the K and this other from the B. Yeah, that's pretty much it. Okay, so like, so given this structure here of parenthesis means that like we have the start of the childs of a node, and the comma is just another node. So like we can basically define a rule set here. Basically, like by traversing this string here. So if found a open parenthesis, we need to consider that as a no, actually, before, yeah, no. Let me focus on your point.
Okay.
Okay. So I'm just gonna test this idea and make sure that this idea is gonna work first. So what I was thinking, my initial idea here is, when I found the open parenthesis, I was just gonna like create a. I'm gonna know that potential like childs of this node is gonna come. So for example, for A, there's an open parenthesis, then I know that B is gonna be a child of it. And then I will add B. And then like I'll traverse through the next character that's gonna be open parenthesis again.
Okay.
Then I know that B is gonna have a child. Then I'm gonna add the E. And for E, I'll check there's no open parenthesis. There's a comma. So which means that I don't need to add any extra child here and just move to the other one. That is the F. So the F is going to be a child of B. Then I will add this. And then I'll open parentheses again and doing the same thing. So, and like there's just one case here. Like I found a comma here. So following this, I know that there's like, you need to think about a general case before. Because, for example, I can find a comma in between the childs, or I can like find an open parenthesis without an extra comma, which doesn't mean nothing. Like, so let me think here. One thing is pretty clear here. Let me just write here. Like, if on open parenthesis, then there's child. Yeah. If found close parenthesis, if found a comma. Oh, actually, yeah, like this. No more child.
Okay.
And found and if found a close parenthesis.
Okay.
Yeah, actually, that's no more childs here. So, like, yeah, I'll just need to define this case here.
Okay.
So let me just test this idea. So
Sure.
imagine that I'm
What
traversing through the string.
Yep. Yeah, get to the main point. Remember, it's not about like, oh, if there's a child, not a child. Get to the main point.
Yeah, so the main point here is to create this tree. You know.
Yep.
So like, for sure, the first element, the first character here, I need to create a node.
Okay.
So I'll create a node A here.
Yes.
And then like, I'll traverse to the second character.
Uh-huh.
There's an open parenthesis, which
Yes.
means that I have to add a, start to add a child because there's a child. It's guaranteed.
Okay.
So, like, I will add, I will turn a logic to add the childs.
Okay.
So then I will move this pointer to B.
Okay.
And I will add this node here.
Okay.
Like, It's gonna be the child of it. Uh, but then I will find a open parenthesis, which means that B has child as well.
Okay.
So, like B, I'll start to add on the child of B, you know. Yeah, I'll traverse to the next one.
Okay.
Then there's the E.
Okay.
That is what I'm going to add here. And then, like when I found the comma, which means that I don't need to like add a child into the node that I'm visiting.
Okay.
So it's just keep on adding childs on B.
Okay.
You know. So like, yeah, I'm just gonna keep on here and visit the F. So given the fact that we found a comma beforehand, F it's child of B.
Isn't
So
E child of B as well?
Oh no. What you said?
You said because there's a comma that F is a child of B, but then you have E as well. So
No, because the E is like the first one, you know.
okay.
So if I found a comma in between, it means that like for me to add another node for
Okay.
the current node that I'm visiting.
Okay.
That is in this case B still, you know. I'm
Okay.
adding to the childs of B.
Fine.
So I don't need to add to the childs of E. You know.
Okay. Sure.
If it was an open parenthesis instead of a comma, I just need to do like
Okay.
this logic for E.
Okay.
Yeah. And then I found the open parenthesis. That means that I need to add another layer of adding childs, but in this case is like the child of F.
Yeah.
In specific.
Uh-huh.
I'll add the child of F.
Yeah.
And yeah, then I will find closing parenthesis, which means that there's no more child to add an F,
Uh-huh.
and I kind of do a backtrack here.
Sure.
Let me put just this A here. Yeah, and then I'll find another closing parenthesis, which means I need to go to the other level, that is B.
Okay.
No, actually, that is A. Yeah. And then, now I'm adding the childs of A.
Okay. I get the idea. Yeah, I think you understand it and I understand it. So, all right.
Good. I'm just gonna try to write a logic for this,
Sure.
like a plan.
Okay.
Okay, so as I mentioned, it's a little bit different here.
Okay.
Like, while you're traversing, if I found, no, actually, let me start over. So, I was planning to traverse through the string.
Yeah.
Like, if I found one character that is different than alphabet, like if it's different than alpha, I will check if it's a comma, open parenthesis, or closing parenthesis. That is the symbols we have. We need to do this, yeah, like the same idea. I'm not going to repeat myself. Okay. So if I found, yeah, actually, if found open parenthesis, I need to add to the current node. Childs, the following nodes. Values. And yeah, I'm just wondering how, yeah, like how I would implement this. Yeah, and Because yeah, I add to the. I think the same problem is repeating. So yeah, I will add like B, right? The same thing. Actually, I can. There's. You said something.
No.
Okay.
Okay.
Actually, there's like two ways to do this. I can do it like in an iterative way,
Okay.
and I can think about doing this in a recursive way as well.
Okay.
That will work.
I would probably suggest the non-recursive way. I'm going to save you some time here.
Okay. Yeah. I'm just wondering one thing. Non-recursive way. So, like if I found the open parenthesis, it's pretty clear. I need to add the current node to the following node. Actually, what I was thinking basically is like. When I found open parenthesis, I know that I need to add to the current node. As I mentioned, I'm just restating my idea here, just to make sure of what I was thinking is right. And if I found like another open parenthesis, I need to add to. That's not so clear still. Add no child stuff. Okay. Yeah.
Okay.
And if closing parenthesis,
Okay.
I just need to like go back.
I don't know what go back means very specifically.
Yeah, well, go back means that means nothing.
Okay, I think I can. I know. You know what? I'm going to give you another 10 minutes, see how far you progress, but I'm pretty sure you're not going to get the problem. And I'll tell you why later, but yeah, go ahead.
Okay. So create a node. I need to add into the node's child. So actually add the nodes. I can think this like I can have a node that is the current one I'm working on. So let me think about this. So for example, like if I'm in node A, and like if I found open parenthesis, the current node, it's gonna be the node A.
Okay.
So I'll just keep adding to this current node child.
Yeah.
And then if I found another parenthesis, basically the instruction is to update this current node that I'm working on. Which means that the current node now is going to be the B. And
Okay.
all of the nodes that I'm going to add is going to be on B. So yeah, that's what I was planning to do. So just let me, before do it, let me just, I'm not sure if that's going to work. So yeah, imagine that the current node is the A, and then I'm traversing here. And then I found the open parenthesis. Then I need to add to the, like all of the following nodes needs to be on the current node child. Then I found a B. We'll add a node to the current child. Then I found another open parenthesis. Then I will update this current node to be the B.
Okay.
Be the B. Yeah, E is going to be added to B.
All right.
But I just want to check one case, like when I'll
Yeah,
go
when
back.
do you back
like,
out?
When yeah.
And what happens on that back out?
Yeah, that's what I was trying to figure out now.
Mm-hmm.
So yeah, imagine that we are on K.
Okay.
No, actually on F,
Sure.
you know, and we just add the K.
Yeah, and all that. All right.
Now I need to go back. Um, Basically, if it was recursive, I can use backtracking.
Sure.
But like, since we are doing this iteratively,
Okay.
uh,
Because effectively, what you're doing is you're building a list of nodes, and then when you backtrack, you attach that to the node.
no, but when I backtrack, how can I have the reference of the parent node? That is my main point here.
Okay. So when you backtrack, won't you be in the parent node?
No, but you said to me to do this iteratively, not recursive.
Yeah, I did. So how do you? Yeah. So how do you remember the a previously node that you visited?
Yeah, I was thinking about like another
Yeah. What
pointer.
what data structure allows you to do that?
If you remember the past.
Yeah.
Oh, I can have a queue.
Sure. I would suggest something
Yeah.
a little different, but
Yeah, I can use a. No, actually, just like the open and closing problem, parentheses. I can have actually a stack, or I'll go into like stack the references of the past nodes.
yeah, there you go.
And then when I found like a close parenthesis, I was just going to just pop from my stack, and then I have a reference for the parent node.
Yeah.
So
Seems pretty simple to me.
yeah. So let's see. Yeah, given this idea of stack, I need to make sure of how it's gonna be. Oh yeah, the idea is pretty clear. So. Yeah, I'll be A, then I'll stack the A here because I found an open parenthesis, then I'm on B. B, I'm adding then I'll found a open parenthesis, which means that I should like stack the B.
Uh-huh.
Oh. Yeah, actually, on B. Then I need to have the A stacked. Then I found the open parentheses on A, before A. Then I will stack the, on E actually. Then I'll stack the A. And then the current node is gonna be the B. Yeah. Let me just write here. So yeah, the idea of okay, like I need to stack the current nodes. Current node's gonna start with like the first created node. And like like if it's different from actually current element is alpha in the alphabet. I just need to like add to the current node child. And then if I found open parentheses, I need to stack the
What
current.
if you're the very first node? Okay, you say current is first create node. Yeah, like what if you start at the very beginning? You know, in the string of A. How does this work then?
Uh,
How's that
so
work? Yeah.
the idea is to like create a node for the first character.
Okay.
Noise. Then yeah, we're gonna be with A created here,
Sure.
and then A is gonna be my current.
Sure.
So current.
Okay.
Then I'll start this traversal like from the one index.
Okay.
And I found like I'll open parentheses that is not alphanumerical.
Okay.
Alpha, not alphanumerical. And yeah, I will just add the following nodes. Like yeah, actually add the following nodes to the current node stack. You know. So. Yeah. Add to the current node childs. Actually, yeah. And because I was going through this direction because I know that the first node is always going to be the root, you know, and I cannot have two roots. So I know that the childs of like the root. Yeah, for this reason.
Yeah, I'm gonna. Do you want to stop here, or you want to keep going? Because I think there's plenty for me to talk about as well.
I think it's better your
Okay,
your
stop
feedback.
here. Yeah. So you're at 24 minutes, by the way. So what do you think you're
24.
doing right? What do you think you're doing
Where's the
wrong?
noise? I was not thinking obvious. Like I tried to be complex.
Yeah.
Like I was not even close to clear.
No, not at all. The
That was- Yeah.
bottom line is you have no idea how to translate what you walked through the code and you had the right idea, right? But then I felt like you threw it away because you didn't have any idea of how that was supposed to look. So let me see if I can do this. Let me walk you through the way I would have done the answer, and maybe that'll give you some inspiration. So I'll paste these notes here, but I think it's better if I just show you. So let's say when you started off, it was pretty much correct, right? Let me move down here, just for my sake, right? I'm here. I'm just like, okay, yeah. When I first look at my character, I recognize I need to create a node, right? So if here's like look at character, create a node. Here, if I go to the parenthesis, it means I am looking at a child. So means that looking at that current node's children. And then here, blah blah blah. I'm looking at that current node's create a node. I'm looking at the current node's children. And so the question then becomes, well, if I have a comma, right? Look, comma, continue to look at the. I'm still looking. Continue to add to the children list, right? And then the moment I get a close parenthesis, it's like I am done. I'm done with looking at all the nodes' children. That's pretty much what. These are the only things that can happen, right? So I have a list of like what exactly these things mean. Follow me so far? Hello? Hello? I think your mic's disconnected. I don't see any sound coming from you. Okay, wait, I think we lost him. Yeah, I think we lost him. Oh, wait, let me disconnect. Hello? Oof. Okay, let's see if we can try getting him back. Give me a sec, guys.
Hello, hello.
Oh, hello. Okay, you're back.
I just had a blackout here.
Oh.
Sorry about that.
It's all good. That's not your fault. Okay. But you understand where we left off, right? You understand, like, what these 4 operations mean, right?
Yeah, I understood.
Okay. Yeah, so this is basically my roadmap, right? So I know that I'm just going to need to, I have these ideas. Now I just need to translate this into code. What does that look like? So, okay. So I'm looking at the character. I create a node. I'm in the parentheses, which means I'm looking at the child, right? Now that means that at any point I can keep going into that previous node's child and child and child and child, forever, right? That's what I see here. So I need to remember the previous node that I was looking at, which is where, okay, well, how do I do that? Once I close out, I need to look at the previous node that I was looking at. So this would be last in, first out. So this would be where I come up with my stack, right? So then I would just, yeah. So literally, I'm just thinking, okay, what does this look like when I take these rule sets? Like, okay, what can go wrong? Oh, yeah. Well, I could be potentially looking into all these forever, right? And then I will pop out. And I need to attach it to the previous node I was looking at. And let's say this list is long. Like, I go to EF, right? I am going into this node. I'm building... This means I'm looking at the current node's children, which means I'm going to be creating my list of children. I'm going to have E. I'm going to add that, comma, F. Okay, so that means I'm going to add to the same list, right? And then this will be the thing that becomes my current node. So this becomes node, right? And then and so on and so forth. So I think we covered pretty much all the cases here, at least briefly talking about it. So let's see if the way I would write this code. So then I would say like iterate through string. Maybe I could do. Should I do this in code or pseudocode? I'll just do it in pseudocode. Screw it. Iterate through string between an I and then index. And then string.len or whatever. You get the idea. If let's say string at I is alphabet, then I will node equals to new node of string at I, right? That's gonna be my character, and then I'll call this current node. Current node is this.
Okay.
Okay, and then now next thing, look at the current node's children. If I open up the parenthesis, f string at let's call what's it called? I'll call this cur char equals string.I. So I'm not rewriting this all the time. And then here, yeah, you get the idea. I mean, it doesn't really. Okay, so then this will just be else if character is open parenthesis, then that means that my current node is going to I'm looking at that children, right? So this means that this needs to be pushed back on the stack. Stack dot push current node or something like that. And then so then else if let's say current char is comma, then I will need to add to my current list. So okay, so this is where the dynamic kind of changes, right? So now I'm like, I know that, okay, well, I have this current node that I'm looking at, and I'm thinking to myself, do I still need to push onto the current node? Actually, it turns out I probably don't. That all I need to do is actually just add it to the list, right? So then this means that if it's open parenthesis, then it should be current node dot list. Should be fine. So then maybe instead, what I do is I create a current list instead.
I see.
Current
I'm following this.
Yeah, so current list equals new current list or whatever, right? And then I try to attach the previous list or something. I'm not quite sure how this is going to play out, but right now I'm just trying it out. And then after that, look at the current, because you add, so then current list, the open and close parenthesis. So the open parenthesis means that the node that I'm currently looking at, actually, it still does need to be pushed onto the stack, actually. Yeah, it actually still does. So then stack.add current node, and then list, and then that means that the last thing, cur char, is close parenthesis. That means that whatever is in my current list, I need to attach to the top of the stack. So that means that stack.peak, I do like stack.peak is dot children equal to current list, and then I will stack.pop, and then current node. Something like this. Let me know if I went too fast, because I might be, because this one, if I stack.add current node, then I need to also, do I need current list or can I just? Maybe I don't need current list actually. Maybe I could just use stack.peak and then top of the current list. Yeah, I could do stack.peak. Because I'm only adding to the current list, right? So stack.peak.children.add. I don't need this. Then and then here stack.add current list if it's open list. Stack.add AlphaNet current node. Yeah. I think that's pretty much how it goes, right? So so you see how I'm just like kind of like saying, hey, this seems right, this doesn't seem right, and I'm just like debating and kind of going back and forth and iterating. And so now I'm like, okay, I have some idea. Let's actually run through this and see what happens. So let's go here, right? So now here I'm iterating through my string, right? Current, and then I'm iterating first letter here, right? A. So now my current node equals to A. Next one, open parenthesis. Open parenthesis is now is this. So now my stack is going to have stack. Let's say it's here. Yeah, actually, let me say I represent the stack down here, right? I'll use this as represent. So now my current node equal to A with no children equals to let's say it's empty, right?
Yeah.
Okay, so now boom. All right, so now I push that in. So now I'm on my next one, B, right? Current node is now equal to B. And so now, like, this should have a comma here, right? So now that I see there's a comma, stack.peak children add current node. Okay, cool. So now I'm going to add B to this, right? And then now I have a parenthesis, right?
Yeah.
Parenthesis means stack.add. So now stack.b here. And so now I'm after the parenthesis E, right? Current node E, comma means I add to the top of the stack, right? And then F, right? F is now my current node, parenthesis. Okay, boom. We push this onto this top of the stack again. So then children will be nothing here, and then F, right? And then now open parenthesis, push this to the top of to K, open parenthesis K, and then K, close parenthesis, push this to the top of this. It's like, okay, actually I realize I do need to commit this. You see, like, even I made a mistake here. So like, okay, so now I need to commit whatever I have going on, and then add, and commit this to the top of the stack, and then pop it. Okay, so cool. Now that I know that my current node F and K exist, right? So let's just store this as a, oh yeah, we're done with these. So I know that children F here. So now I'm back here. Right?
Yep.
Okay, so now my current node is F. And then I see I have another close parenthesis, right? Now I need to commit this. Right? And then boom, now this is just something we're done with. I'll just put it down here. And now my current node is B. Right? And then now I see I have a comma. Right? So the comma, I look here. Oh, add this. Oh wait, no, B should not have a comma here actually.
Yeah, they should not have a comma. I'll say that, but
yeah. So now that we push this onto here, right? B, and then we go on, right? Now it's going to C. So you see here, like basically the way I solved this problem, I didn't do it. I never did it in my head. I just straight up just iterated. I think this is the way it's supposed to go. I have some idea. Let me just fill in the gaps. Does that make sense?
Yeah.
So this is the difference between how I would do it and how you do it. I think, again, you're trying to do it piece by piece. I'm like saying, I have a rough general idea. Let me just commit to it and fully acknowledge, hey, I'm not quite sure if this works. Let me just test it out and run through it. And it's a lot easier to do this and just come up with like a incomplete kind of buggy solution and then just kind of like walk through it and then revise it if I need it. As long as I'm like 80% there, right? All I need to know is like the last 20% details. Like for instance, this stack peak children.add and whatever. But I know for sure the skeleton of like me alphabet open parenthesis comma close parenthesis is correct. I know that for sure. The last 20% I wasn't sure about is whether or not I need like a new children list or I could just add. And then once I started doing it, it became obvious. Oh yeah, I can just stack.peak to the top and add the children.
I see.
So and
Like,
this is how they get faster.
The minor points, just the minor points.
Yeah. So this is what I mean. I like how are you getting closer to solving the problem? What is the problem that you're trying to solve here, right? And then straight up just doing that. And it's just like, oh yeah,
But
this is-
like, how like one point, I'm still not sure. Like, how are you so sure of like an idea and you commit to it without like, I think the instinct part, as you mentioned, but
I would say it's a little bit of the instinct part. You're asking me like, why would I do this? How can I commit to my idea? Why am I so confident in it?
yeah, basically, yeah, that's it.
Okay. So the part I'm confident in is that I know I'm gonna have to iterate through every single character. I know that's 100% certain, and I know that I'm 100% certain that when I read these characters, they represent nodes, right? And I'm certain that I know that this parenthesis here means that I'm looking at that the children for that node, right? I know that 100% for certain based on like this cursory idea. I know that,
you're right.
So
Yeah.
the overall idea is I'm going to be having a node, and then I'm going to be building the list for that node. I have something to grab onto that I know that's 100% undeniable, and I know that these commas here will be here to separate each one of the children. I know that that's 100% certain. What I don't know is how to handle and I vaguely have some idea of how to handle the recursion. I know that I'm going to use some stack. I don't know what that looks like. But just that enough is like, I know that these are not going to change, so I can at least commit to the skeleton of my structure. I have a few facts that I know are pretty, I'm almost 100% certain in, right? All that's left is, like, how do I make sure that I go in and out of this recursion? That's really the only question left. And so I've like, I have like 5 factors that I can spit out there, and 1 factor that I have no idea about. I think those are pretty good odds.
And you figure out on the fly the rest.
Yeah, exactly. It's like, even if, like, let's say I'm completely wrong about how to handle the stack, I know at the very least that the rest of this is, is correct, so I don't have to occupy my own headspace with it. And so you gotta, I would recommend you rewatch the way I did it, because I was like kind of like off the cuff. But yeah, it's like, do I need a current list for this? Like, oh wait, well, can I get away with not using it, because all I really need to do is attach it to the previous node? But I actually have that access to the previous node just by using a stack peek. So why don't I just use stackpeek.children.add? It's just that
I'd say that if I had this idea of the stack, like I'll get closer. I'm not gonna get the answer. I don't know, but I'll probably get closer. But like this, I think the delta, like watching you solving this question, I had this idea of like we need to have lists, like kind of iterate through lists inside lists,
Yeah.
like and create this tree.
Yeah.
But like the main point here I was hammering is like, how can I go back to the previous node? I was not clear,
Yeah. That wasn't clear to me either, but then I realized, okay, well, now that let's all I did was like walk through this visually and say, okay, let's say I close this out, right? And how do I get back to attaching this to A? Like let's say like all this is handled, right? It's like, okay, well, how do I reference back A? Like, okay, well, each time this is a recursive structure, right? So I'm instantly thinking recursion, and I'm instantly thinking stack.
Yeah, recursion analogous to stack.
Yeah, it's basically making that very quick association, and it's because I've screwed up with like doing things consistently as a iteratively and recursively, right? And so basically, that was it. Just basically me saying, oh, I've screwed this up in the past before. I know this is gonna be a tool I'm probably gonna reach for.
Okay. I see.
Yeah, so that's basically the way I thought about it. It's literally just because I've made that mistake before in the past, and I'm very cognizant of I'm probably gonna need it.
And one question, like about for me to not make this mistake again. Do you think like practice more questions with the stacks? I don't know, like because see maybe that's a potential weakness, right?
I wouldn't say it's a potential weakness. I think it's more like that association should have been there, because sometimes we ask you to do questions iteratively or recursively.
Yeah.
And it's really knowing, hey, wait, this is like these ideas are pretty closely related and similar to one another. Let me go ahead and just reach for that tool in my tool belt. Just in case that happens. I was like, I think I need a stack. So it's like, okay, let me double check. Am I going into a recursive structure? Yes. It's like that checklist. Remember, like those patterns that we did. It's like literally recognizing the characteristics of the problem, and it's just one of those things where it's like, oh, we have a recursive structure that I probably don't want to handle recursively. I mean, I could do it recursively, but I've already committed to this iterative idea. So if I need to have the recursive structure and I need to reference something I've previously seen before, I'm probably going to use a stack. And I could be wrong. I could maybe it's just going to be a queue. But 9 times out of 10, because I see recursion, I'm going to associate with stack. So.
To be honest here, like for the questions of recursion, for the chapter of recursion and trees.
Yeah.
Like, of course, like recursion, I will do recursion. I will use recursion.
Right.
But for the trees ones and for remember the pattern of subsets.
Yeah.
Like I gave preference for recursion because I was training this. But like for trees and like all of the other things, I was giving preference to solve using recursion. I never to be honest here with you, I never try like both approaches. Like to try an iterative and a recursive. So given this fact, I think that's a good idea for me to put into practice.
Yeah, try it a few times. If you've never seen it before, then that's probably why I never connected. Yeah, so I definitely would recommend you at least give that one a try. Like you, breadth first search with the queue, and then, there's no other way to do it, I think. And then depth first search, both recursively and iteratively, just as an exercise, just so you understand what that looks like.
Yeah, I'll do it.
Okay. Yeah, I think we talked about a lot, but hopefully, I think rewatching how I did the problem and rewatching the stream and rewatching your own performance is going to really help. And you'll understand, like, hey, I need to do this. I was like, this seems somewhat right. Let me commit to this idea and then revise because I have a good idea of where this code is going to go. It's being able to do that. That's going to help speed up your time.
Like, I think that boils down to the question of, he has the instinct because you already did this mistake in the past, so you knew how to. You knew how to not repeat it again, So.
It's not so much that. It's more like, hey, here are the tools you're probably going to need to use to figure this problem out. So the mistake would have been committing to the wrong tool. But it's like, hey, wait a minute, I recognize this. I know what tool I need to use. But yeah, some part of it is the experience and instinct. But to be honest, I think you already have as much as I do. All that's left is putting it together.
Okay, and keep on practicing. I
mean, I don't regularly do these problems. I mean, I only regularly give the same problem or like same few problems for an actual coding interview when I do interviews with Uber, right? So I'm like way out of practice. I don't even remember the proper answer to this one. And so it's like you should be way more experienced and more methodical about this than I am. All I'm doing is just using some heuristics and things that seem kind of right and that have pretty good odds of actually working. And then just using those.
I see.
I don't need to be precise. It's like I don't need to be that precise. I just need to be approximately correct. And then
to see if the candidate is doing the right thing. Yeah.
Yeah, it's like I know, like I said, like I know for sure that I'm going to be using I'm going to traverse the string. I'm going to be evaluating based on a character by character basis, and I know I need to do this at least these things. I know that's like almost 99% certain, like 100% certain on that. The rest is just the handling the recursion. So let me clear out that headspace so I can at least make sure that this recursion is gonna or this recursive structure is gonna be handled right. So.
Yeah, that makes sense.
Yeah.
You're focusing on the right things.
It's like focusing on being approximately correct instead of being precisely wrong. So.
Well, yeah.
It's like it's just being able to aim in that general direction and then just like from there eliminate what it can't be and then move on. So that's it. I know it's a little bit abstract. But I think that if you try putting this into practice with a lot more, I think you should do some more complex problems. Like the challenge section from EPI might be a good one.
Oh, the honor classes.
Yeah, those will probably help you.
Okay, I'm gonna go to these ones.
Okay. Yeah.
Instead.
Other than that, I still think that your core approach is still correct. It's just it takes you too much time to do it, and you keep like going back and forth between the testing. But yeah, it's about cleaning that up and making that faster now. So at least if I gave you an infinite amount of time, you'd probably be able to solve it. So
That is not the real world.
Not the real world.
Uh,
It's about getting. It's
yeah,
about those heuristics.
Okay.
So
Can you repeat, please? I just don't got it.
yeah, I'm saying like honors classes, and then just do the. It's just about the heuristics that you're using to try and get the answer. Okay.
Okay. So just one thing here about the training.
Yeah.
Like there's still a few questions that I think it's valuable for me to solve.
Okay.
Is it okay if I like commit to solve them?
Yep.
Because it's not so clear still, you know.
That's
and I
fine.
had trouble in the past. And then it's gonna reduce. I mean, like the following questions from the 1 month plan,
Sure.
and then I jump for the honor classes
That's fine.
once.
I think that's fine.
okay?
It's
Okay.
yeah, because again, what we really want to do is make sure that you can get these heuristics down. That hey, this seems approximately correct, and I'm pretty and I can I know that these are going to be things in the problem that I need. Absolutely, and it's just being able to reduce the amount of headspace. It's like being able to execute on everything we've practiced. And I really want you to
think
focus on that. See if like you can see if that will work. It's kind of hard for me to describe, admittedly, but
No, but I will focus on that. I think that's the as you use highlight, right? Highlight from this.
right.
Yep.
Yeah. How do you get
Okay.
faster? All right. I'm gonna let you go then.
Okay then.
All right. Sounds good.
Okay, man.
All right. Keep me
Thank you.
posted on all the scheduling. All right.
I'll keep you. Any update, I'll text you.
All right. For sure. Take care, man.
Bye. Take care, too.
Bye bye. All right. Cool. Any questions from the crowd? Hi, Michael. What's up? Yeah. I mean, he's doing pretty good. I think that it's just basically just getting faster at these problems. He's at least complete and careful. That's a change from before. Now it's making sure that we get a little bit faster at these problems without losing the correctness. So, if there's no other questions, then I guess I'll stop the stream. Let's see. Going once, going twice. All right, cool. Thank you all for joining me. I guess I'll stop the stream here. If you guys, I think we'll have a stream on Tuesday. I will be off next week, on next Saturday. I'll be going to Omaha for the Berkshire Hathaway annual shareholders meeting. Yeah, so hopefully we can give M all the feedback he needs right now for Tuesday. So yeah, that will be at 8 p.m. Pacific Standard Time. And hopefully you guys can join me. Thank you all for joining me today. And I'll see you all next time.